Hello everyone, I'm Paul and today we're solving problem 11, container with most water. This is a medium one, and next I will show you my thought process and efficient solution. We are given an integer array height, so let's say we are given this, and each element here represents some height. And we need to find two lines to form a container such that it contains the most water. And finally, we need to return the maximum amount of water that we can store with only one container. So if we are given this array, we can take this and these lines, and here we can contain this amount of water, which is 49. And how do we reach this value? Well, this is index 0, 1, 2, 3, 4, and so on. So we need to get this area. And how do we do this? Well, we take the index for the right bound, which is 8, index for the left bound, which is 1, and we do 8 minus 1 times the minimum height among these two, which is 7. So this times 7 is 7 times 7, which is 49. So we return this. Now here we have two heights that are larger than the height for the winner container. But this doesn't mean anything. For example, this is not the winner container. The area for this is 6 minus 1 times 8, which is 5 times 8, 40. And 40 is smaller than the area for the winner container, which is 49. So this is not the result. And how do we get the winner container? One possible approach here is to try every combination of two different bounds. Remember that every container has two bounds, left and right. And maybe the winner container is made with these two bounds or these two bounds. And maybe you're thinking about trying every possible combination of two bounds. So how can you do this? Well, you can use a double nested for loop and try every combination of two different elements, and that's how you try every possible bound. The problem is down here in the constraints. We know that n is smaller than 10 to the power of 5, and this is 10,000. So if we want to try every container, this will require 10,000 square iterations, and we are using square because we have a double nested for loop, and this is too much. This will throw the LE, which is time limit exceeded. So we need to think about something more efficient. And the trick here is the following. Instead of trying every possible container, we are trying only the most relevant ones. So we will have two pointers. Left is initially here at index 0 and right is at the last index. And we are getting the area for the current container. In this case, we do 8 minus 0 times the minimum height among this and this, which is 1. So this times 1 is 8. The area for this container is 8. So now we can say the result is currently 8. And here we have two options. We can either move the left pointer one step to the right or move the right pointer one step to the left. And remember, we are trying to get the maximum amount of water. So here the trick is we always want to move the pointer corresponding to the minimum height. In this case, this is smaller than this, so we update left one step to the right. That's how we can get the maximum amount of water. And we are only comparing relevant containers. Now left is here, so we have this and these bounds. We know this is the winner container, so we take the minimum among this and this, which is 7 times 8 minus 1. We know that the result for this is 49, and 49 is greater than 8, so we replace this with 49. And given that this height is smaller than this one, we move the right pointer one step to the left. So now we have this container, and the area for this is 7 minus 1 times the minimum height among these two. So we do 7 minus 1 times this height is 3, and the result for this is 6 times 3, which is 18, and 18 is smaller than 49, so we keep 49 here. Given that this is smaller than this, we update right again. Now we have this container. The area here is 40. 40 is smaller than 49, so we keep 49 in the result. And given that these two heights are equal, we can choose either to update the left pointer or the right pointer. It's exactly the same. So let's say we update left. Now we have this container and the area is smaller than 49, so we update the minimum among this and this, which is this. Now we have this container, this is a small area, we continue, we update the minimum, the pointer corresponding to the minimum height. Now we have this container, this is a small area, we update left again. Now we have this small container, we update left again. And given that now right is equal to left, we can end this loop and return 49. So this is the entire approach. Instead of comparing every possible container, we are only comparing the most relevant ones. And by doing this, we are reducing time complexity to big O of n. We are iterating every height only once, and space complexity is big O of 1. So with this in mind, let's go with the code. So we have two pointers. Left is initially at index 0 and right is at length height minus 1. Sorry, this is height. And the result is initially 0. We want to return this result, and here in between we can say while left is smaller than right, the result will be the maximum among the result and the area for the current container. Remember, how do we get the area? We do right minus left times the minimum among the two heights, height left and height right. And if height left is smaller than height right, we update left. And here you could use smaller or equal also, it's exactly the same. If these two heights are equal, we can choose to either update left or right. It's the same. Else, right minus equal 1. So this is the entire code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.